All right, so welcome to lesson 16. This is what is it? Computer science or code.org computer science discoveries, lesson 16, collision detection. Um, this is in the game design and animation unit, unit 3 of that CSD and code.org. This one, part of this activity we're supposed to go through with a partner, but I'm just going to show you the worksheet that's associated with this, and then we'll kind of go from there. So the class learns about collision detection on the computer. Pairs explore how computers should use a sprite location and size properties and math to detect whether two sprites are touching. The class then uses the is touching block to create different effects when sprites collide, including playing sounds. Last, they use their skills to improve this side scroller game that they started in the last lesson. Okay, so these lessons are going to continue just like our last unit to build off of each other, so make sure that you are completing them to the fullest of your abilities, and we'll go from there. So abstraction, a simplified representation of something more complex. Abstractions allow you to hide details to help you manage complexity, focus on relevant concepts, and reason about problems at a higher level. Debugging, finding and fixing problems in an algorithm or a program. And then an if statement is the common program structure that implements conditional statements. So that's the if else, things like that. So our new code, sprite is touching a specific target, and then sprite.debug. We'll look into that one a little bit further. But this is that worksheet that we're supposed to go through. Like I said, we're going to maybe just talk through it and kind of go from there. So press continue here. Look at the frog jumping game to the left. It looks like the game from the last lesson, but the frog moves and moves the mushroom if it hits it. What code do you think would help the computer to know whether two sprites are touching? So we press run. Okay, so it moves. If I press the space bar, okay, that's kind of like a little twitch, but okay. If you notice, it kind of touches it just a little bit beforehand, though, which isn't the best. See there? Oh well. All right, press finish. All right, balloon. The code below uses the sprite's X and Y position to check whether they are touching. It will change the balloon sprite's animation when the track or when the tack touches it. Use the arrow keys to move the tack until it touches the balloon. You do not need to change any code on this level. Read the if statements inside the draw loop and find the different sprites properties and how they are compared. Discuss the code with your partner. Would you want to write code every time you checked whether sprites are touching? So this is that if the balloon is or the tack is touching. And we use the arrow keys. Yeah. Okay, so that's the code for if the tack and the balloon's X and Y value are touching. Okay, so pretty extreme. Instead of just doing, we've got conditionals, ands, less thans, ors, another and, a greater than, pluses and minuses, dividing them by 2 when they're moving. Okay, so it gets pretty extreme. Instead, we can just use a simple line of code. Okay, is touching. Writing out the math each time you want to check whether two sprites are touching can take a while, so a programmer created the is touching block, which can check whether one sprite is touching another sprite, the target. So pretty much what's happening is this is touching block that we're going to have, this red one here, is all of that code that you saw from the last lesson all smashed into one block. And it's doing the math for you, which is really, really nice. That's what computer programmers continue to do. They find things that are used often or things that they want to make easier, and they simplify them by creating a library of instructions and then making just a specific block do a specific thing. So the computer is still doing the same math as in the previous program, but you don't have to worry about it because another programmer already did all that work. So inside the draw loop, drag the is touching block into the if block. Sprite is touching target. Okay, we need to change the sprite to balloon and target to tack. I don't know if the tack needs to be in double quotes or not. We'll find out. I don't think so. Press run. Nope. Because those are both variable names, we can leave them without the double quotes. Okay. Again, if you need a pause during this at any time to make sure that you don't get behind on any of the levels, if you miss something, if I'm going too fast, make sure that you pause so that you get it all done. All right. When the apple hits the blender should turn on. Use the is touching block to make the blender shake back and forth when the apple sprite touches the blender sprite. The shaking motion is already coded using the random block. You just have to check when the two sprites are touching. Challenge, can you make the apple disappear when it touches the blender? Okay, so our apple, actually, yeah. Apple is touching blender. Okay, I'm gonna start shaking, and we want the apple to disappear. If the apple is touching the blender, then I'm gonna just make my visible to 0. Right? Not visible. Oops, there we go. Okay. You can also use code to play a blender sound. Use the play sound block from the world drawer to play this sound when the apple touches the blender. You need to paste the address of the sound into the block so it looks like this. Play sound. Okay, so I'm going to copy this out of here. When it touches the blender. Oops. Control V. Oops. Control V. Interesting. I think that definitely was a bit overkill, but all right. Rainbow horse. When the rainbow touches the horse, it should turn into a unicorn. This sounds like my program. Do this. Use the if is touching and set animation blocks to change the horse sprite's image when the rainbow touches it. The unicorn image is already loaded in the animations tab for you. Let's run this and just see what this looks like. Okay. All right. So if let's throw this right in here. If the come on. If the horse is touching the rainbow, whoa, horse is not spelled with a Q. The rainbow, then we want the horse dots. Let's set the horse's animation to the unicorn instead. Honestly, I think that might be it. No. Let's just do, oh, in the draw function, duh. Huh, wait, yeah. There we go. I was like, why is that not working? All right, is that all it wants? Yeah. So that has to be in this draw function, otherwise it's not gonna work, which makes sense. I just wasn't thinking. Oops. Alright, debugging collisions. The balloon is popping before the tack touches it. When sprites aren't doing what you expect, use the debug block to get more information about why the sprites are behaving the way that they are. Can you find out what's wrong in the code below? Run the code and use the arrows to move the tack to the balloon. Okay, much sooner. In the code below, change the balloon.debug to equal false. Where's that at? Oh, to true. Add a new debug block to the code and set the tack sprite debug property to true. Add a new debug code here. Set the tack debug block sprite property to true. Oh, okay. Okay, so you can see why that is the way that it is. Interesting. Okay, by just adding in those debugs, it adds in those grids for you. Kind of a cool little thing that we could do if we needed to. We're not going to resize the... Okay, so in that instance, you'd have to just resize the balloon in the animations tab so that the balloon didn't get popped so early. Can you use the isTouching block to decide whether you should increase the score in the game? The score is stored inside the score variable. It is displayed on the screen using the text block. Is it an up arrow maybe? Whoa. Okay, but okay, so if they're touching, use the if touching blocks to determine whether your bunny has caught the carrot. Okay, so loop carrot back to the right of the screen, make the bunny jump. When the bunny touches the carrot, okay, it wants it here. Add 1 point to the score. Control. If down here, when the bunny touches the carrot, add 1 to the score and put the carrot back off the screen. Okay, but that happens over here. So if sprites bunny carrot. All right, so we added in this if statement if the bunny is touching the carrot. Okay, and what we're gonna do is if it has, do the following 3 things. Use the counter pattern on the score variable to increase the score. So we're gonna go here. We have a counter created, variable score equals 0. So we're gonna increase that variable by 1 if it's touching the carrot. So we're gonna make sure that you do this x equals blank, not the variable. We're not redefining a variable, we're just adding to it. The score is going to equal score plus 1, right? So we need to add in plus score plus 1, or however many points you want the carrot to be worth. Reset the carrot's X position off the right hand of the screen. I feel like that's being done. Let's just run this and see what happens. Whoa. Why does it think that I'm touching the carrot? Set the carrot's Y position with a random number between... Oh, it's only doing it once. Ah, I get it. Okay. Okay, so I need to reset, as soon as it touches it, I need to reset the carrot's position to the right side of the screen, otherwise it's going to think that I am. So if we touch it, because otherwise, if you notice there, it kept counting it up. Carrot.x equals 450. And then set the carrot's Y position to a random number between, okay. So we're pretty much just copying this stuff in this code here. But we need to do it when this is for the carrot just moving. This is when we press the up arrow. Now this is when we touch the caret. Because otherwise it's just going to keep counting it every single time that I touch the caret, and we want it to reset as soon as I touch it. Okay. Oh, there we go. And that one's, I don't think I can even touch that one. Okay, so that resets. Up and down. Oof. I didn't even jump fast enough for that one. All right. Any other ones? Nope. That's it. Okay. Remind you guys again, if you need to pause for these to make sure that you're doing them correctly, feel free to pause. Improve your game. Now that you know how to use the is touching and play sound, you can make some fun things happen when your sprites run into each other. Note, the play sound block now has an extra parameter called loop that can be set to true or false. If the parameter is true, the sound will continue to play in the loop. Add at least 2 effects when your sprites glide. Challenge. Add a scoreboard to the top of your screen. What do we have going on? Whoa, that moves super slow. And nothing's happening. Okay. Okay. All right. Okay. If set it down here. If the frog touching the mushroom, right? Is that what we call that, mushroom? Okay, then we are going to set a counter. We gotta make our variable first. Let's add it here. Whoops. I'll make a variable. Oops. 0. All right. So we've got if the frog is touching the mushroom. We created our score up at the top. Now we're going to add to it. And then that's going to be a plus. So if the frog is touching the mushroom, we're going to do score equals score plus 1. We'll reset that mushroom back to the side. If we look, if the mushroom has gone off the left edge of the screen, this is what's going to happen. And we're going to move it back. So if the frog is touching the mushroom, we want to set the mushroom's x value. Mushroom.x equals 350, it looks like. Okay, so if the frog touches the mushroom, we're moving it back. We don't want to do that random y value just because we're not gonna. We wouldn't have that. We wouldn't have that happen. Mushroom's not gonna randomly appear in the sky. I mean, you can if you really want to, but let's just run and see what we've got right now. So if the frog comes in contact with the mushroom, it's just going to keep resetting it. Kind of boring. I am going to have it randomly move in the y direction. That just seems boring if it's not. Mushroom.y equals, and let's just do, where is my, do I not get a random number generator in this? Okay, I guess I don't get to do that. Never mind. All right. We can do this play thing, this play sound. If it comes in contact, sound, let's choose an achievement. I don't care. That's stupid. Sure, that's ridiculous. We'll do that one, and we're not going to have a repeat. Loop, true or false, parameters, at least two fixed interface glide. Let's have it shake. Sprite, but I can't do that if I don't have a random number again. Whatever, we're just gonna, okay, yeah, let's add the scoreboard though. If you go to drawing and you go to, let's do text string. Just put this down on the, let's just put this towards the top. It actually doesn't matter. Text or that's going to need to be filled with a variable though. I'm going to see how they did in this last one. So we can do it the same way. Draw score, fill black, text size, score, blank, text, score. Interesting. Simple for ourselves. I don't know if I can actually copy that code. So what I'm going to do is I'm just going to snip this out and move this over to my other screen. And come back to this one here. Draw. Let's go here, enter down. Okay. Fill black. Size 20. Text. This one. 4, 5, 5. These two as well. 5, 5. 20, 20. Text. This one's going to be the variable, so we have to get rid of the double quotes here and just make it score. It's going to be at 75. Add those out. Okay. Now. That's ridiculous. All right. All right. That's very entertaining to me. All right. I need to go somewhere. Anyway. Okay. Next one. Oh, perfect. That's it. Interesting. So we can do a set collider. We'll probably take a look at some of these later. But for now, so that this video doesn't get insanely long, go ahead and just press continue. Again, make sure that you screenshot this code, making sure that you've got this running, and again, make sure that you have this run, okay, so that I can see this running. Might as well have a couple little scores go up there at the top, and then you'll need to scroll down probably a couple times, screenshot this stuff so that it's done. Okay, that is code.org lesson 16. That's in unit 3, game design and animation.